National Electrical Code Section 230.71 requires that each service, feeder, and branch circuit be protected by an overcurrent protective device. Section 408.13 requires that each panel board be equipped with a main overcurrent protective device. The main breaker serves as the main disconnect for the panel board and provides several advantages. Firstly, it allows for easy isolation of the panel board from the power source for maintenance or repairs. Secondly, it limits the fault current that can flow through the panel board, protecting the conductors and equipment inside. Thirdly, it provides coordinated protection with the main overcurrent protective devices in the main power distribution board. An exception to this requirement exists if the panel board is located on a single-family dwelling and is fed from a single overcurrent device such as a main breaker in a service panel. However, this exception does not apply to multi-family dwellings or commercial buildings. The existing panel boards on each floor should be equipped with main breakers to comply with the NEC. The main breakers should be sized appropriately for the conductors and loads connected to the panel boards. To elaborate, let's consider a typical residential building with multiple floors. Each floor has its own panel board to distribute electricity to the various circuits within the apartments or living spaces on that floor. Without a main breaker in each panel board, the entire floor's electrical system would be directly connected to the main power distribution board, often located on the ground floor. This creates several potential hazards and inconveniences. For example, if an electrician needs to perform maintenance or repairs on a circuit in one of the apartments, they would have to shut off the power to the entire building or at least a significant portion of it from the main distribution board. This can disrupt service to other tenants and create unnecessary downtime. With a main breaker in each panel board, the electrician can simply turn off the breaker for that specific panel board, isolating the electrical system on that floor without affecting the rest of the building. This makes maintenance and repairs much easier and more efficient. Another important benefit of main breakers is their ability to limit fault current. A fault current is an abnormally high electric current that flows through a circuit when there is a short circuit or other type of electrical fault. If a fault current is allowed to flow unchecked, it can cause conductors to overheat, insulation to melt, and equipment to be damaged or even explode. Main breakers are designed to trip quickly in the event of a fault current, interrupting the flow of electricity and preventing damage. By limiting the fault current that can flow through the panel board, the main breaker helps to protect the conductors and equipment inside the panel board, as well as the branch circuits that are fed by the panel board. Furthermore, main breakers provide coordinated protection with the main overcurrent protective devices in the main power distribution board. The main breakers in the panel boards are sized to trip at a lower current than the main breaker in the main distribution board. This ensures that if a fault occurs on a branch circuit, the main breaker in the panel board will trip first, isolating the fault and preventing the main breaker in the distribution board from tripping. This coordinated protection helps to minimize the disruption of service and prevent widespread outages. The exception to the main breaker requirement for single-family dwellings is based on the assumption that the electrical system in a single-family dwelling is typically simpler and less complex than that in a multi-family dwelling or commercial building. In a single-family dwelling, the service panel, which contains the main breaker, is usually located in close proximity to the panel board. This allows for easy access to the main breaker in the event of a fault or the need for maintenance. However, in multi-family dwellings or commercial buildings, the service panel may be located some distance from the panel boards, making it less convenient to access the main breaker. Additionally, the electrical systems in multi-family dwellings and commercial buildings are typically more complex and have a greater potential for faults. Therefore, the NEC requires main breakers and panel boards in these types of buildings to provide an additional layer of protection. To comply with the NEC, the main breakers and the panel boards must be sized appropriately for the conductors and loads connected to the panel boards. The size of the main breaker is determined by the ampacity of the conductors feeding the panel board and the total load connected to the panel board. The ampacity of the conductors must be equal to or greater than the rating of the main breaker. The total load connected to the panel board must not exceed the rating of the main breaker. It is important to consult the NEC and other applicable codes and standards to determine the correct size of the main breakers for the panel boards. In summary, the NEC requires main breakers and panel boards located on separate floors of a residential building to provide several important benefits, including easy isolation of the panel board for maintenance or repairs, limiting the fault current that can flow through the panel board, and providing coordinated protection with the main overcurrent protective devices in the main power distribution board. The exception to this requirement for single-family dwellings does not apply to multi-family dwellings or commercial buildings. To comply with the NEC, the main breakers must be sized appropriately for the conductors and loads connected to the panel boards. When evaluating the existing panel boards for compliance, several factors need to be considered. Firstly, the age and condition of the panel boards should be assessed. If the panel boards are old or damaged, they may not be suitable for reuse and may need to be replaced. Secondly, the ampacity of the conductors feeding the panel boards should be verified. If the conductors are not sized appropriately for the load, they will need to be replaced. Thirdly, the overcurrent protective devices in the panel board should be inspected to ensure that they are in good working order and are properly sized. Fourthly, the grounding and bonding system should be inspected to ensure that it is in compliance with the NEC. Fifthly, the labeling of the panel board should be reviewed to ensure that it is accurate and up to date. Once these factors have been evaluated, a determination can be made as to whether the existing panel boards can be reused or whether they need to be replaced. If the panel boards are to be reused, they may need to be upgraded to comply with current code requirements. This may include installing new main breakers, replacing conductors, or upgrading the grounding and bonding system. If the panel boards are to be replaced, they should be replaced with new panel boards that meet all current code requirements. The new panel board should be sized appropriately for the load and should be equipped with main breakers. The installation of the new panel board should be performed by a qualified electrician in accordance with all applicable codes and standards. Let's break down some of the NEC sections mentioned to provide a clearer picture. NEC section 230.71 deals with the maximum number of overcurrent devices a service can have. While it doesn't directly mandate a main breaker in every panel board, it sets the stage for overcurrent protection, which leads us to section 408.15. NEC section 408.15 is more specific. This section, titled Main Overcurrent Protection, generally requires that panel boards be protected by an overcurrent protective device. This is where the main breaker requirement stems from. It ensures that the entire panel board assembly is protected from overcurrent situations. Let's think about why this is important. Without a main breaker, a fault within the panel board or in one of the branch circuits could lead to a significant overcurrent event. This could damage the panel board itself, the wiring connected to it, and potentially even start a fire. The main breaker acts as a first line of defense, quickly disconnecting the power supply to the panel board in such a scenario. The exception mentioned for single-family dwellings fed by a single overcurrent device is a key point to understand. This exception typically applies when the panel board is directly fed from the service equipment and that service equipment already has a main breaker. In this case, the NEC recognizes that the service equipment's main breaker provides adequate overcurrent protection for the panel board. However, this exception is narrowly defined and doesn't apply to multi-family dwellings or commercial buildings where the electrical systems are more complex and serve multiple tenants or businesses. In a rehabilitation project, especially in a multi-family dwelling, relying solely on the main breaker and the main power distribution board on the ground floor may not be sufficient. The panel boards on each floor are essentially acting as subpanels, and each subpanel should have its own main breaker for the reasons previously discussed, that is easy isolation, fault current limitation, and coordinated protection. When selecting and sizing main breakers for panel boards, there are several factors to consider. Firstly, the ampacity of the panel board's busbars must be considered. The main breaker should not have a higher ampacity than the panel board's busbars, as this could overload the panel board and create a safety hazard. Secondly, the calculated load connected to the panel board must be considered. The main breaker should have an ampacity that is sufficient to handle the calculated load, but not so high that it would allow an overcurrent condition to persist without tripping. Thirdly, the interrupting rating of the main breaker must be considered. The interrupting rating is the maximum fault current that the breaker can safely interrupt. The interrupting rating of the main breaker should be equal to or greater than the available fault current at the panel board location. Available fault current calculations can be complex and often require the expertise of a qualified electrical engineer. In addition to the NEC, local codes and regulations may also have specific requirements for main breakers and panel boards. It is important to check with the local authority having jurisdiction to ensure that the installation complies with all applicable codes and regulations. Let's consider a practical example. Suppose you have a 3-story residential building with 4 apartments on each floor. Each apartment has its own panel board located within the apartment. The panel boards on each floor are fed from individual breakers located in a main power distribution board on the ground floor. In this scenario, each of the panel boards in the apartment should have its own main breaker. This will allow for easy isolation of the electrical system in each apartment for maintenance or repairs. It will also limit the fault current that can flow through each panel board, protecting the conductors and equipment inside the panel board. Furthermore, it will provide coordinated protection with the main overcurrent protective devices in the main power distribution board. The main breakers in the apartment panel board should be sized appropriately for the loads in the apartments. This will typically involve calculating the total load in each apartment and selecting a main breaker with an ampacity that is sufficient to handle the load. The main breakers should also have an interrupting rating that is equal to or greater than the available fault current at the panel board location. The importance of proper labeling of panel boards cannot be overstated. Each circuit breaker should be clearly labeled to indicate the circuits it controls. This makes it easier to identify and isolate circuits for maintenance or repairs. It also helps to prevent accidental disconnection of critical circuits. The panel board directory should be updated whenever changes are made to the electrical system. The panel board directory should be legible and accurate. The use of a computer-based panel board labeling system can help to ensure that the directory is always up to date. Grounding and bonding are critical for electrical safety. Grounding provides a path for fault current to flow back to the source, causing the overcurrent protective device to trip and to energize the circuit. Bonding connects all metal parts of the electrical system together, creating a low impedance path for fault current. The grounding and bonding system should be inspected regularly to ensure that it is in good working order. Any deficiencies should be corrected immediately. The grounding electrode system should be installed in accordance with the NEC. The grounding electrode system should consist of a grounding electrode conductor connected to a grounding electrode such as a ground rod, a metal water pipe, or a concrete encased electrode. The size of the grounding electrode conductor should be determined in accordance with the NEC. The bonding conductors should be sized in accordance with the NEC. The bonding conductors should be connected to all metal parts of the electrical system, including metal conduit, metal enclosures, and metal equipment. Arc fault circuit interrupters, or size, are devices that are designed to protect against arc faults. Arc faults are dangerous electrical faults that can cause fires. Size are required in many areas of the home, including bedrooms, living rooms, and dining rooms. Size should be tested monthly to ensure that they are working properly. Ground fault circuit interrupters, or GFCIs, are devices that are designed to protect against ground faults. Ground faults occur where electricity leaks to ground. GFCIs are required in wet locations such as bathrooms, kitchens, and outdoor areas. GFCIs should be tested monthly to ensure that they are working properly. Surge protective devices, or SPDs, are devices that are designed to protect against voltage surges. Voltage surges can damage electronic equipment. SPD should be installed at the service entrance and at sensitive electronic equipment. Electrical safety is everyone's responsibility. Always use caution when working with electricity. If you are not comfortable working with electricity, hire a qualified electrician. Never overload circuits. Use extension cords safely. Keep electrical equipment away from water. Test SIs and GFCIs monthly. Replace damaged electrical cores and plugs. Turn off power before working on electrical equipment. Smoke detectors should be installed in every home. Smoke detectors should be tested monthly to ensure that they are working properly. Carbon monoxide detectors should be installed in every home. Carbon monoxide detectors should be tested monthly to ensure that they are working properly. Electrical inspections are an important part of maintaining a safe electrical system. Electrical inspections should be performed by a qualified electrical inspector. Electrical inspections can identify potential hazards and ensure that the electrical system is in compliance with code. Electrical permits are required for many types of electrical work. Check with your local authority having jurisdiction to determine whether a permit is required for your project. Hiring a qualified electrician is essential for ensuring that electrical work is performed safely and in compliance with code. A qualified electrician will have the knowledge, skills, and experience necessary to perform the work correctly. A qualified electrician will also be licensed and insured. When selecting an electrician at multiple bids, check references. Verify that the electrician is licensed and insured. Get a written contract. Ensure the contract includes the scope of work, the price, and the payment schedule. In conclusion, ensuring compliance with the NEC regarding main breakers in panel boards is crucial for the safety and proper functioning of electrical systems, especially in multi-family dwellings and similar buildings.